Cybersecurity constantly attempts to push forward and find new and better ways to protect our networks. Yet, as these products delve further into specialized areas of an enterprise, managing them becomes impossible. Worse, the people required to run these products, cybersecurity experts, are impossible to find. And in time, the problem is only going to get worse. Complicating things further, cybersecurity's definition of the enterprise is not the enterprise we see today, and these tools, for the most part, do nothing to protect those systems. And most of the time, existing protection takes down operations and can cost more money than the initial attack. A new solution is needed that moves security out of the way and protects not just the traditional enterprise, but everything we use today in business, government, and our personal lives. Bear Systems provides an invisible software agent that sits at the bottom of any device, from an IoT sensor to a cloud server, and locks down those devices and their communications. Bear provides this ubiquitous protection through a series of local systems that collectively make a virtual private enterprise, or VPE. A VPE enables disparate systems to be seamlessly connected together and allows devices local hyper-secure connectivity regardless of actual geographic location. Bear works over every type of network and over any type of protocol, from Ethernet, Wi-Fi, and Bluetooth to RF, satellite, OTA, and microwave. Let's see how this works in real life. On the right side of the screen is the unified vBear visual management platform. It enables Bear's cybersecurity protection without requiring cybersecurity expertise. Within this portal, you can see a series of local systems which are defined as a local domain controller, or LDC, and all devices locally connected to that LDC. In the Bear virtual private enterprise you are seeing, we have physical devices in Houston and Boulder, and virtual devices located in our Google and AWS deployments. Clicking on a given local system gives details for each device along with the policies they are running. Currently, the devices are running an ADS off policy, which I will explain shortly. At the top of this list, you can see Chat Server A and Chat Server B. Over here is a remote desktop connection into Chat Server A, and here is a remote desktop connection into Chat Server B. We downloaded some simple malware from the internet to demonstrate our unique approach to security. The current device policy has a series of registered applications as well as a series of allowed IPs and ports. If any other traffic attempts to communicate off of the device, then the monitoring workflow has been instructed to send an alert to the Bear visual system. Note, there are no signatures being used, no files being looked for. This is low-level communications command and control. As you can see, this simple malware is stealing data from Chat Server A and porting that data to Chat Server B. If you look back to the right side, in vBear, you see that an alert has appeared both in the local system and in the details on Chat Server A. This is where Bear starts to differentiate. While many products provide some level of reporting, none provide full-cycle remediation options, and none do so in a manner addressable by a non-expert admin. In this case, a visual tool has been matched to the potential exploit, and that tool shows the operational impact of using this visual remediation option. The visual tool also provides details on whether a device will be power cycled. All an admin needs to do is choose when to run the visual tool. Now look at Chat Server A while I click the OK button. And as you see, the malware was instantly killed, and status has returned to normal. If you look back to the right, note again that ADS off policy. One of the largest issues facing current cybersecurity efforts, especially agentless security, is the intrusive nature of their intervention. In fact, the only option for agentless protection is to isolate a device or system and take down operations for hours or even days. Not a good idea. But from where Bear operates, the entire notion of zero-day attacks hardly applies. To demonstrate this power, we are going to push a policy to Chat Server A that turns on ADS, or what we call our Anomaly Defense System. The Anomaly Defense System, ADS, watches packet-level communications on the device just as with the previous workflow. In this case, however, if any anomalous activity occurs, Bear sandboxes that process and keeps it isolated on that device until an admin, or an AI-driven system, can provide remediation. To provide context, we also downloaded a simple peer-to-peer chat program, hence the name chat server, and as you can see, they are exchanging messages. Now, we are going to launch the same malware again, but this time, as you can see, the malware is unable to communicate. The alert still appears, and the same workflow as before is used to kill the malware. But at no time did Bear ever interfere with operations. This is the first system to proactively detect and stop malware in its tracks before even one packet of data was able to leave the device, and it is enabled for non-security experts. Going back to that local system, I want to cover one more aspect of cybersecurity: automation. There are some fascinating tools on the market that rely on humans to do all of the work, from alerts that do nothing to remote-enabled operating system controllers. While these sound and look great, the reality is that enterprises are scaling much too fast, and IT organizations cannot keep up. In fact, the average group can only handle 10 alerts per day, and the rest are ignored. Humans simply cannot keep up. True AI assistance is required, and Bear is the only company that can provide this type of AI-enabled help. The reality is that AI machine learning has to make a continuous series of changes to devices, observe the response, and then make additional changes. Every other security tool sitting in the enterprise causes disruptions when making device changes and prevents actual end-to-end AI capabilities. Bear is different. Bear's agent sits underneath devices and makes changes and adaptations with no unwanted disruptions. Bear uses this capability to clean data at the point of collection and send device-agnostic, contextualized anomalies upstream. The next layer in the system readily sees anomalies, not just within one device or a subsystem, but across a range of systems. And as this pattern matching capability goes upstream, behavioral detection grows more sophisticated. The Bear agent consists of tiny policy-driven workflow engines and not hard-coded security behaviors. Bear pushes to each device blockchain-secured policies that control all device behavior using our patent-pending, lightweight, distributed blockchain system. When a pattern is matched, Bear sends a remediation workflow down to the impacted devices. This automated system enables complex responses at the point of attack or device malfunction. If a pattern has not been seen before, the data is sent to the actual AI system in Bear, which uses the cleansed contextual pattern to make a determination about what is occurring. At this point, admins interact with the AI and assist in remediating issues mainly through intent-based rules. Even in these cases, default workflows can isolate anomalies and fix minor issues automatically. Instead of thousands of false positive alerts with little to no remediation options, the Bear end-to-end AI system provides non-security admins the help they need to succeed in an ever-increasingly hostile digital world. Thank you for watching our demonstration, and please contact us for more information.